Hello, and welcome back. Today we are looking at absolute value equations and inequalities. Most students respond when asked about absolute value that it makes everything positive. That's only part of it. Absolute value is giving the distance from zero. So if I look at this statement, the absolute value of u equals a, what this is saying is that u is a units from 0. Looking at a number line here, 0, I can go a units to the right, putting us at positive a, or I can go a units to the left, putting us at negative a. So the absolute value of u equals a, then u is equal to a, or u is equal to negative a. And this definition we're going to use to set up all of our problems. But we're going to continue to remind ourselves as we're working through them that absolute value is our distance from 0. If we can remember that and keep on reminding ourselves, it makes the problems a little bit easier to set up. When you're solving an absolute value equation like this one, 5 minus the absolute value of 1/2 x equals 3, your first step is to isolate the absolute value. In other words, you want to get it all by itself. So we're going to start by subtracting 5 from both sides. Negative 1 times the absolute value of 1/2 x equals 3 minus 5 is negative 2. And to get rid of the negative 1, we can either multiply or divide both sides by negative 1. So we get the absolute value of 1/2 x equals 2. Rewriting that, the absolute value of 1/2 x equals 2. Now we're going to take this and rewrite it as two equations. What this is saying is that 1/2 x is exactly 2 units from 0, which means that it could be 2 or it could be negative 2, which sets up our two equations without absolute value. 1/2 x equals 2, or 1/2 x equals negative 2. Solving both by multiplying both sides by 2. X is equal to 4, or x is equal to negative 4. So let's try another one. The absolute value of 1 minus 2x plus 6 equals 9. Again, starting with isolating the absolute value, we're going to subtract 6 from both sides. We get the absolute value of 1 minus 2x equals 3. That definition of absolute value says that this 1 minus 2x is 3 units from 0. So 1 minus 2x could be 3, or 1 minus 2x could be negative 3. And we solve these two equations independently. We get x equals negative 1 for our first equation. And x equals 2 for our second equation. So again, we have two solutions, x equals negative 1 or x equals 2. Let's try another one. The absolute value of 2x plus 1 divided by 3x plus 4 equals 1. Notice that our first step is already done for us. The absolute value is already by itself. So again, we're going to use that definition. What this is saying is that this rational expression is exactly 1 unit from 0. So the rational expression 2x plus 1 over 3x plus 4 could be 1, or it could be negative 1. To solve this rational equation, we want to first clear our denominator, so we're going to multiply both sides of the equation by that denominator. On the left-hand side, those two are going to cancel out. We have 2x plus 1 equals, distributing the 1, we get 3x plus 4. And this is a nice baby equation, pretty easy to solve. Combine like terms. We get x equals -3. And we'll do the same thing for this second equation. We'll end up with the same thing on the left-hand side, 2x plus 1. On the right-hand side, when we distribute the -1, we get -3x minus 4. And in this equation, we're going to perform our steps in a little bit different of an order just so that we don't end up with a negative coefficient on x. I'm going to start by adding 3x. I do this because then I got a nice, pretty positive 5x. We get x equals -1. So here are our two solutions, -3 and -1. Now when we think about an inequality, again, less than, greater than, less than or equal to, greater than or equal to, but we are now including that idea of giving distance from 0. So we're going to look at these two examples. The absolute value of x is less than 3, the absolute value of x is greater than or equal to 3. And we're first going to just translate what those statements mean. If the absolute value of x is less than 3, this is saying that x is fewer than 3 units from 0. So if I think about this on a number line, here's 0. If I'm less than 3, then I've got to be between 3 and -3. I'm not including my endpoints because it's strictly less than 3. So this shaded region is where my value of x lies. Anything in this shaded region is going to satisfy this inequality. If I've got the absolute value of x is greater than or equal to 3, this is saying that x is 3 or more units from 0. So here's our value of 0. If I'm more than 3 units from 0, here's +3. I'm going to be to the right of that. If this is -3 and I'm more than 3 units from 0, I'm going to be to the left of -3. And in this example, we are including our endpoints because we're saying that x is 3 or more units from 0. So again, my value of x lives in this shaded region here or this shaded region here. So for solving an absolute value inequality, first step is always the same. We're trying to isolate the absolute value. But now since we're dealing with an inequality, we have to make sure we remember the rules for solving inequalities. Specifically, when we multiply or divide by a negative, we have to flip the inequality symbol. Then we'll rewrite it. If the absolute value of u is less than a, just like that previous example, when we had the absolute value of x is less than 3, then that means that u is a units from 0. Or less than a units from 0, which puts us in this region right here, which is how we set up this inequality. -a is less than u is less than a. If the absolute value of u is greater than a, then u is greater than a, or u is less than -a. Just like before, if this is 0 and we're more than a units from 0, then we are to the right of +a or to the left of -a. And we'll change from parentheses to brackets if it changes from a strictly less than, strictly greater than, or greater than or equal to, less than or equal to problem. So let's look at an example. 3 minus the absolute value of x plus 1 is less than 1/2. First up, we need to isolate the absolute value. So we're going to subtract 3 from both sides. -1 times the absolute value of x plus 1 is less than 1/2 minus 3 is -5/2. There we go. And we can use our calculators to simplify that a little bit quicker. We've got that negative out front, so we need to get rid of that by either multiplying or dividing by -1. But remember that when we multiply or divide by a -1 in an inequality, we need to flip this inequality symbol. So this becomes the absolute value of x plus 1 is greater than, forgot to multiply this side by -1, positive 5/2. That definition of absolute value says that x plus 1 is more than 5/2 units from 0. Notice I keep using that definition. It's going to help me in setting up my two inequalities without the absolute value. If x plus 1 is more than 5/2 units from 0, then that means it's going to be to the right of positive 5/2 or to the left of negative 5/2. These shaded regions are representing our x plus 1. This left-hand side says that x plus 1 is less than negative 5/2. This right-hand side says that x plus 1 is greater than positive 5/2. And now we solve these two inequalities just like we did in our last lesson. Subtract 1 from both sides. X is less than negative 7/2. Or x is greater than 3/2. And we can write this solution in interval notation as well. This is from -infinity to -7/2, union 3/2 to positive infinity. The absolute value of -4x plus the absolute value of -5 is less than or equal to 1. First thing we can do is simplify this absolute value of -5. It's always going to be the same. Absolute value of -4x plus positive 5, because -5 is exactly 5 units from 0, is less than or equal to 1. Subtract 5 from both sides. The absolute value of -4x is less than or equal to -4. Now let's think about this. This is saying that this guy, this -4x, is fewer than -4 units from 0. Now, if I think about that, is that possible? Can I be less than a negative distance from 0? And the answer is no. So there is no solution for this problem. Makes things nice and easy. The absolute value of x plus 4 plus 3 is less than or equal to 5. Isolating the absolute value of x plus 4 is less than or equal to 2. This is saying that x plus 4 is fewer than or equal to 2 units from 0. So thinking about my number line, here's 0. If it's less than 2 units from 0, then it's sandwiched between -2 and +2. This is where my x plus 4 lives. X plus 4 can represent any of these values because all of these values in this shaded region are values that are less than or equal to 2 units from 0. Which sets up the inequality -2 is less than or equal to x plus 4 is less than or equal to 2. To solve this compound inequality, we're going to subtract 4 from both sides. From all sides. negative 6 is less than or equal to x is less than or equal to negative 2. And writing our solution in interval notation from negative 6 to negative 2. That ends our lesson for today. Just to recap, guys, when we're solving absolute value, we want to continue to remind ourselves that we're dealing with the distance from 0. Notice I didn't go back to the rules that we set up for all of those, even though that's an option. I continue to remind myself, what does absolute value mean? It means that whatever's inside the absolute value bars is either equal to that distance from 0, or it is less than or greater than that distance from 0 if we're looking at an inequality. So try to continue to prompt yourself with those definitions, and good luck solving absolute value equations and inequalities. We'll see you next time.